Cell 1. In this cell, we delve into the fundamental concepts of the RFM model, which stands for recency, frequency, and monetary value. Understanding these three dimensions is crucial for businesses aiming to identify their most valuable customers. The essence of this model lies in the idea that customers who have made recent purchases, do so frequently, and spend a significant amount typically represent the core of a company's revenue. To break it down further, recency evaluates how recently a customer has made a purchase. The guiding thought here is that the fresher the transaction, the more likely the customer is to engage again. Next, we consider frequency, which measures how often these transactions occur over a specific period. A higher frequency generally indicates customer loyalty and satisfaction. Last but not least is monetary value, which assesses the total amount of money a customer spends. This helps identify not just loyal customers, but those who contribute significantly to the bottom line. The logic behind using RFM is straightforward. If we can pinpoint customers with high scores in all three categories, we can focus our marketing efforts effectively, ensuring that we nurture relationships that yield the highest returns. However, learners should be cautious about how they define these categories. Different businesses may have varying benchmarks for what constitutes recent, frequent, or valuable. As we move forward to the next cell, we'll leverage these definitions to create actionable metrics. We'll explore how to segment our customer base using these insights, allowing us to tailor our marketing strategies based on these critical customer attributes. This will enhance our understanding and application of RFM analysis in practical scenarios. Cell 2. In this cell, we're diving into a pivotal next step after establishing RFM, or recency, frequency, and monetary value. The goal here is to translate RFM analysis into actionable customer segments that can significantly influence business decisions. First, we start with identifying key segments characterized by their RFM scores. For instance, customers who score high in all three areas, recency, frequency, and monetary value, are labeled as champions. These customers are vital to our strategy, as they tend to be fiercely loyal. By recognizing them, we can implement rewards and exclusive offers that not only honor their loyalty, but also drive repeat purchases. On the flip side, we'll also pinpoint at-risk customers, those who may have low recency scores, but once had high frequency and monetary scores. Understanding this group is critical for launching win-back campaigns designed to re-engage those who have slipped away. Additionally, we'll find new customers who show promise with high recency but low frequency. This indicates that they have recently made a purchase but haven't yet established a strong buying habit. Tailoring onboarding and nurturing strategies for these individuals will be essential for fostering long-term relationships. Beyond just marketing, these segments provide valuable insight for forecasting customer lifetime value, or LTV, particularly for those who may exhibit high frequency with moderate spending. This insight allows businesses to strategize upsell or cross-sell opportunities effectively. We should also consider positioning RFM as a feature in churn prediction models, as historical data shows it to be quite predictive. Different segments often exhibit distinct behaviors, influencing product engagement strategies, such as how frequently they upgrade plans or adopt new features. In essence, the flow from RFM to actionable segments allows businesses to implement targeted actions that are measurable, increasing conversion rates, improving customer retention, and enhancing overall revenue. Looking ahead, the next cell will likely delve deeper into how these segments can be operationalized, exploring specific examples of targeted campaigns that have proven impactful. Cell 3. In this code cell, we create a simulated transactions dataset and derive RFM metrics for customer segmentation. RFM stands for recency, frequency, and monetary value, which are key indicators used in marketing to assess customer behavior and segment them effectively. The first part of this cell generates a dataset using NumPy and Pandas. We set up a random number generator and define parameters for the number of customers and transactions. We produce a data frame that includes customer IDs, transaction dates, and transaction amounts, effectively mimicking real-world data. By doing this, we establish a foundation for analyzing customer interactions over time, which is crucial for understanding their purchasing habits. Next, we calculate the RFM metrics. First, we establish a snapshot date that is 1 day after the last transaction. This helps to determine how recently customers have engaged with the brand. We group the transactions by customer ID and compute their recency, frequency of transactions, and the total spent amount. This process not only aggregates valuable data, but also sets the stage for meaningful insights into customer behaviors. The RFM scores are generated in the next step, and here we assign scores on a scale from 1 to 5. Recency is measured such that a lower score indicates more recent activity, while frequency and monetary values reward higher scores. It's essential to ensure that the data is well distributed, and potential issues with outliers could skew the scoring process. Following the scoring, we define a function to categorize customers into segments based on their RFM scores. These segments, such as champions or at risk, offer profound insights into how to tailor marketing strategies. Finally, we print the distribution of these segments and display the top entries in the RFM data frame. This summary will help in identifying trends and focusing marketing efforts on specific segments that could drive revenue. As we move to the next cell, we'll likely delve deeper into how to visualize these segments or further analyze the relationships within our data. Cell 4. In this cell, we're diving into the concept of customer segmentation, an essential part of understanding customer behavior and improving business strategy. By evaluating each customer's recency, frequency, and monetary value, we can categorize them into meaningful segments that guide marketing efforts and resource allocation. The cell outlines the foundational metrics used in this segmentation approach, starting with recency, which reflects the days since a customer's last interaction or purchase. This metric helps identify how engaged a customer currently is. Then we have frequency, capturing the number of transactions over a set period. This tells us how often a customer returns to make purchases, providing insight into their loyalty and engagement levels. Next is monetary value, which sums up the total spending of each customer. This financial aspect is crucial because it highlights which customers contribute the most to revenue. Each of these three metrics, recency, frequency, and monetary, is transformed into a score ranging from 1 to 5, giving us a structured way to compare customer engagement levels. As we analyze these scores, we can classify customers into segments like champions, who are the most valuable with high engagement across the board, or at risk, who may have previously been active but are now showing signs of disengagement. Understanding these segments allows businesses to tailor their marketing strategies, focusing efforts on those who are most likely to respond positively. It's important to be mindful of potential pitfalls, such as assuming all big spenders are loyal, or overlooking customers labeled as hibernating. Their inactivity could suggest missed opportunities for re-engagement campaigns. Looking ahead, the next cell will likely build on this segmentation framework, applying these concepts to real data to illustrate how they can inform targeted marketing strategies and improve customer retention. Cell 5. In this cell, we're diving into the construction of a key metric set called RFM, which stands for recency, frequency, and monetary value. These metrics help us analyze customer behavior over different time frames, providing valuable insights for marketing and customer retention efforts. The code defines a function, RFM window, which processes transaction data to extract these RFM metrics for specified time intervals. First, we're ensuring the transaction dates are in the correct date-time format, which is crucial for accurate time calculations. The time frame for analysis is built around the latest transaction date in the dataset, plus 1 day, allowing us to focus on recent customer activity. Within the function, we evaluate transactions that occurred within a defined number of days. For instance, the function identifies transactions from the last 30, 90, or 365 days. The data is then grouped by customer ID to calculate 3 main components: the frequency of transactions, the total amount spent, and the last date of purchase for each customer. This aggregation forms the backbone of our RFM analysis. After calculating the last transaction date, we derive the recency metric by determining how many days have passed since the last purchase. It's important to note that we drop the last date column from our output to streamline the resulting data frame, and we rename the columns for clarity. Next, we apply the function to create 3 separate RFM data frames for each time frame, and subsequently merge them into a comprehensive dataset. This final RFM table will show a consolidated view of customer activity across all time periods, filling in any gaps with zeros for customers who didn't engage in certain time frames. The output allows us to quickly gauge customer engagement and spending patterns. Looking ahead, the next cell will likely focus on interpreting these RFM metrics, helping us segment customers based on their behavior for targeted marketing efforts and better strategic decisions. Understanding how to leverage this data will be critical for driving engagement and revenue growth. Cell 6. In this cell, we're implementing a winsorization technique, which helps in mitigating the effects of outliers on our dataset. Winsorization is particularly useful in scenarios where we want to maintain data integrity by capping extreme values, ensuring our analysis isn't skewed by a few anomalies. First, the function defined here, named winsorize, takes in a series and a parameter p, which defaults to 99%. Essentially, the function calculates the pth quantile of the provided series and uses this value as a cap. By applying this cap, we ensure that any values higher than the determined quantile are replaced with this threshold. This is crucial in preparing our data because outliers can distort statistical measurements and lead to misleading insights. After defining this method, the script then takes a closer look at a specific column, M365D, from the data frame known as RFM. The function is applied to this column, and the resulting capped values are stored in a new column called M365DW. This helps in preserving the original data while providing a more robust version for analysis. Furthermore, the script computes logarithmic transformations for both M365DW and another column F365D. Log transformations are particularly effective when dealing with skewed data since they help stabilize variance and enable better interpretation. The results are stored in new columns labeled log M365D and log F365D. As we display the first few rows of the modified data frame, we're set to see how these changes look in practice. It's important to remain mindful of the assumptions built into this process, especially regarding the appropriateness of using winsorization and logarithmic transformations for the specific data at hand. In the next cell, we are poised to analyze how these adjusted metrics affect our overall insights, leading to a deeper understanding of the dataset's patterns and trends. Cell 7. In this cell, we're defining a function that calculates quantile scores for a dataset, which is an essential part of analyzing customer behavior through RFM, recency, frequency, monetary metrics. This process helps segment customers based on their purchasing habits, allowing businesses to target their marketing efforts more effectively. The function begins by taking a series of values and assigning a rank to each, which serves as a basis for our quantile scoring. The variable high is good allows us to specify whether higher values are preferable, which is particularly important for metrics like recency, where fewer days since the last purchase is better. The logic then sets up the quantile labels, starting from 1 up to the specified number of quantiles, or Q. If higher values aren't seen as better, these labels are simply reversed. After defining the function, we apply it to the RFM data frame. For recency, we use the function with the high is good flag set to false, because we want to reward customers who made a purchase more recently. In contrast, frequency and monetary values are measured positively, so we leave that flag set to true as we score those metrics. As we calculate these quantiles, we store the resulting scores in new columns, effectively creating a summarized report of customer behavior. Then, we combine these individual scores for recency, frequency, and monetary into a single score, labeled RFM sum, which aggregates the three metrics into a single figure. We also construct a unique RFM code that encapsulates these three metrics in a format that can easily be used for further analysis, giving us a clear and concise representation of customer segmentation. Upon executing this cell, we display the first few rows of the updated RFM data frame, revealing how customers are categorized based on their purchasing behavior. This is a critical step, as understanding these segments will enable more targeted strategies in the next stages of our analysis, where we may delve deeper into customer profiles and potential marketing strategies based on these insights. Cell 8. In this cell, we're diving into a critical step of our clustering analysis, specifically using k-means to segment our data based on certain customer metrics. This process is essential as it helps us understand different customer behaviors, enabling more targeted strategies down the line. We start by preparing our features, focusing on the recency, frequency, and monetary value of customer transactions over specified timeframes. This selection represents vital aspects of customer behavior that can significantly influence how we group them. By applying the standard scalar, we ensure that our features are on a similar scale, which is crucial for k-means since it relies on distance calculations. It's important to note that without this normalization, variables with larger ranges could disproportionately affect the clustering outcome. Moving into the clustering itself, we specify 6 clusters, a choice that may vary depending on prior analysis or domain knowledge. We also set a random state for reproducibility, meaning we'll achieve identical results every time we run this code. As k-means goes through the data, it assigns each customer to one of the clusters based on the features we've standardized. After fitting the model and predicting the clusters, we create a new column in our data frame to label these segments. This helps us seamlessly integrate our clustering results with the original data. The next step involves summarizing the characteristics of each cluster, where we aggregate key metrics such as the number of customers in each segment, their average recency, frequency, and monetary spend. By sorting these results based on customer count, we can quickly identify our largest groups, leading to invaluable insights about our customer base. As we look forward to the next cell, we anticipate using this cluster summary to inform our marketing strategies, tailoring our approach based on the distinct profiles we've created. This segmentation will facilitate more personalized communication, increasing engagement and potentially driving sales. Cell 9. In this code cell, we're diving into the process of enriching our recency frequency monetary, or RFM, dataset. The focus here is on determining how long each customer has been active, which we measure in days since their first transaction. Understanding customer tenure can offer valuable insights into behavior patterns and lifecycle stages, making it a crucial aspect of our analysis. We're starting by grouping our transaction data based on unique customer IDs, allowing us to identify each customer's very first transaction date. This is achieved by utilizing the .min function, which effectively extracts the earliest date for each customer, indicating when they began engaging with our business. This new information is then merged into our existing RFM dataset, ensuring we have a complete picture of customer activity by associating the first transaction date with each ID. Following this, we calculate the tenure in days by subtracting the first transaction date from a reference date, which we have designated as of. This provides a straightforward way to track how long each customer has been part of our journey. In this workflow, it's essential to ensure that the as of date is appropriately set, as it serves as the focal point for this calculation. An oversight here could lead to misleading tenure values, affecting our overall analysis. Finally, we display the first few rows of the enriched RFM dataset to visualize our progress. This step not only gives us an immediate glimpse into our new tenure days column, but also allows us to verify if the merge was successful and whether our calculations are in line with expectations. In the next cell, we can build upon this newly created tenure data, potentially analyzing how customer lifespan might correlate with purchasing behavior or exploring further enhancements to our RFM model. This could lead to actionable insights that drive more targeted marketing strategies. Cell 10. In this cell, we're diving into the heart of customer segmentation by analyzing the RFM data in detail. The goal here is to group customers based on their behavior and derive insights that help understand each segment's characteristics, which can be crucial for targeted marketing strategies. At its core, this code uses the pandas library to work with a data frame called RFM. We start by grouping the data by a variable labeled cluster, which represents different customer segments. Within each segment, we then apply various aggregations to calculate metrics that provide a clearer picture of customer behavior. For example, we are counting the unique customers in each segment by employing the unique function on customer ID. This is essential because it gives us insight into the size of each customer segment. We also calculate averages for key metrics like recency, frequency, and monetary value, using functions such as mean across the respective columns. These averages help us understand customer trends in terms of how recently they made a purchase, how often they purchase, and how much they typically spend. Additionally, we compute the average tenure, capturing how long customers have been with the business, and the total monetary value over the past 365 days, providing a comprehensive view of customer loyalty. One critical aspect to keep in mind is the sorting of results by the number of customers within each segment. This allows us to see which segments are the largest and potentially the most lucrative, guiding future marketing and retention efforts. It's crucial to ensure that the original data is clean and structured, since inaccuracies may skew our results. Looking ahead, the next cell is likely to take these segment profiles and utilize them to create actionable insights or visualizations, helping us strategize marketing efforts tailored for each specific group. This transition is vital as it allows us to directly apply the segmented insights gleaned from this analysis. Cell 11. In this cell, we're defining a function that plays a crucial role in segmenting customers based on their recency, frequency, and monetary value, often referred to as RFM analysis. By categorizing customers into distinct segments, businesses can tailor their marketing efforts, ensuring that they effectively engage each group according to their behaviors and potential. The function named label RFM takes a single row of data as input, extracting the recency, frequency, and monetary values of individual customers. With this information, it evaluates a series of predetermined conditions that determine how to classify each customer. For instance, if a customer has high scores in all three categories, 4 or more, they are labeled as champions, indicating they are valuable to the business. Alternatively, if a customer shows high recency but lower frequency and monetary values, they may be identified as new customers, which implies they are worth nurturing. In addition, there are specific classifications for customers at risk, those who are inactive, and even those spending a lot, but not returning frequently. Throughout this classification process, it's important to note that the assumptions behind each segment are grounded in typical business patterns and customer behavior. But they may not cover every possible situation. Thus, a critical observer should recognize that the labels might need adjustments based on context or additional insights. After defining the classification function, the cell then applies this logic across the entire dataset using the apply method. This effectively assigns each customer a segment based on the conditions we defined. The results of these classifications are then summarized through the value counts method, which counts how many customers fall into each segment, providing valuable insights into the customer distribution. Finally, to facilitate a clearer understanding, the cell displays the top rows of the updated data frame, allowing us to observe the newly assigned segments. Looking ahead, the next steps will likely involve analyzing these segments in more detail, tailoring marketing strategies, or exploring how these classifications impact overall business performance. Cell 12. In this cell, we're diving into the critical strategy of monetization actions tailored for different customer segments, while also establishing a framework for measuring profit effectively. This matters because understanding how to maximize profits through targeted actions is essential for driving revenue growth and ensuring a sustainable business model. The logic unfolds by categorizing customers into specific segments: champions, loyal active customers, new customers, big spenders, those at risk, and hibernating customers. Each segment has been assigned tailored actions to optimize engagement and drive monetization. For instance, champions are highly valued and can benefit from premium upsell opportunities, VIP perks, and referral schemes, all of which are likely to yield a high return on investment. Meanwhile, loyal active customers are nudged toward bundles and subscription offers, keeping them engaged while also increasing their lifetime value. New customers receive onboarding support alongside incentives to encourage their second purchase, helping them transition into more loyal behaviors. Big spenders who are cooling off can be re-engaged through personalized offers and reminders, ensuring they feel valued without losing their business. The at-risk segment requires a delicate touch, with win-back offers and reducing any friction in their purchasing process. Finally, for those hibernating, the focus is on low-cost reactivation strategies, or in some cases, a strategic decision to suppress their spending activities until they show signs of re-engagement. It's also crucial to understand the profit model here as we look at revenue and costs. The profit calculation essentially revolves around recognizing that profit equals revenue minus costs. We need to estimate the revenue uplift expected from each campaign, as well as account for various costs associated, including discounts, marketing expenses, and potential losses from fraud. As we prepare to move to the next cell, we'll likely explore how to refine these strategies further for data-driven insights, or explore specific metrics to assess the effectiveness of these tailored actions. Understanding this measurement process will be vital in ensuring that our monetization efforts translate effectively into actual profit gains. Cell 13. In this cell, we focus on analyzing customer segments to estimate expected incremental profit from targeted marketing efforts. This step is crucial because it helps us understand which segments may yield the highest returns, guiding us in allocating resources effectively. We begin with an assumptions data frame containing several segments, each with different probabilities of response, expected uplift percentages for their spending over the past 90 days, monetary incentives for participation, and contact costs. These variables play a vital role in calculating the expected profit from marketing initiatives tailored to each segment. The probabilities associated with each segment reflect the likelihood that customers will respond positively to outreach efforts, while the uplift percentages indicate how much additional revenue we anticipate from those who do engage. A key part of the analysis involves merging this assumptions data with an existing data frame called RFM, which presumably contains customer information. This merge enables us to align the relevant customer data with the corresponding segment assumptions, paving the way for more detailed profit calculations. Next, we calculate the expected incremental profit for each customer. This formula takes into account the probability of response, the projected uplift in spending, the contribution margin, any incentives offered, and the cost of contacting each customer. It's quite important to understand that each of these variables can significantly impact the bottom line. Once we have these calculations in place, we group the data by customer segments. This aggregation summarizes the unique number of customers, the total spending over the last 90 days, and the expected profit by segment. Sorting this information by expected profit allows us to identify which segments are most promising for targeted marketing efforts. As we interpret the results from this cell, we should remain mindful of assumptions made around response rates and spending behavior, as inaccuracies here could skew our profit estimates. Looking ahead, the next cell will likely build on this analysis by exploring strategies to further optimize our marketing spend based on the insights we've gathered. Cell 14. In this cell, we're analyzing how the RFM model can specifically inform profit strategies by determining who should receive incentives. This is essential for optimizing marketing efforts and ensuring resources are effectively allocated. The cell outlines two primary considerations, one for identifying customers who would genuinely benefit from incentives, and another for recognizing those who should not be targeted. First, we look at the customers who should receive incentives. Here, the focus is on individuals who have low recency but high historical value, often referred to as at-risk customers. These are the patrons who haven't engaged with the brand recently, yet have shown significant purchasing behavior in the past. By offering them incentives, we can entice them back into the fold, potentially reviving their interest in spending. Additionally, we highlight new customers, particularly those who recently onboarded. Their conversion into loyal, repeat buyers can hinge on timely and well-designed incentives. On the flip side, we identify groups that should not receive these incentives. Customers labeled as champions typically purchase without needing extra motivation, so providing them with incentives may simply result in wasted resources. This is often referred to as subsidizing natural behavior. Furthermore, we encounter hibernating customers who might appear as candidates for discounts, but in reality, the return on investment can be minimal unless we engage through low-cost channels. Overall, this cell prompts us to consider the strategic placement of incentives within our customer segmentation framework. It encourages a nuanced understanding of customer behavior and the potential impacts of our marketing strategies. As we move forward to the next cell, we'll likely delve deeper into measuring the effectiveness of these approaches, assessing which incentives truly drive engagement and profitability. Cell 15. In this cell, we're focusing on refining our approach to incentivizing customers, specifically by reconsidering how we allocate rewards to certain groups, such as champions. The core idea is to recognize that these loyal customers might already be likely to make purchases. Therefore, offering them additional incentives could be a cost without substantial benefits. This adjustment can significantly enhance our marketing ROI by directing resources where they will yield the best returns. Next, we look at how we measure the impact of these incentives. The initial model we're using assumes that incentives only apply when a customer responds, which is valid, but it is crucial to evaluate the uplift being measured as a percentage of the expected profit over a 90-day period. However, this could underestimate the true benefit, especially if the total uplift is treated as a fraction of spending rather than profit. It might be worthwhile to consider whether the uplift should be calculated as additional transactions with an average ticket size in mind, to potentially capture the full value of customer interactions. Additionally, we should focus on targeting only the top segment of customers within each market area. Instead of adopting a broad contact everyone strategy, we should be selective and prioritize outreach to our most valuable customers. This refined targeting approach can lower our overall contact costs while simultaneously enhancing the efficiency of our marketing efforts. Looking ahead, the next cell will likely delve deeper into how we can segment our customer base and prioritize communications more effectively based on these insights. By honing in on high-value interactions, we can further boost our marketing strategy and overall profitability. Cell 16. In this cell, we're calculating the expected incremental profit for different segments based on specific assumptions about how much profit we expect per responder. This step is crucial because understanding the profit dynamics helps in making informed decisions about marketing strategies. The process begins by defining a list of expected incremental profit values for each responder in various segments. These values represent fixed dollar amounts, showcasing how much additional profit we anticipate from each segment, rather than a percentage. Following this, we merge this assumptions data with our existing RFM data, which helps us connect customer segments with their respective profit assumptions. Now we really dive into the calculation of expected incremental profit for each segment. We're using a formula that takes the proportion of responders, adjusts for the profit per responder by subtracting any incentives given, and then deducts the contact costs. This ensures that we're not just looking at gross profit, but are accounting for the expenses associated with reaching out to those customers. It's important to recognize that this calculation hinges on our assumptions about responder behavior and financial metrics. If the assumptions are even slightly off, the results can significantly vary, which could lead to misguided marketing investments. Hence, clarity in our assumptions is key. As we display the first few entries of our assumptions, we're effectively setting the stage for understanding how these figures will play out in our overall profit analysis. Moving forward, the next cell will likely take this analysis further, applying these insights to strategic decisions or validation of the profitability of different marketing tactics. Cell 17. In this cell, we're diving into an analysis to assess the financial viability of different segments based on specific metrics we've calculated. This is crucial for understanding which segments provide the best return on investment, especially when planning marketing strategies. The first operation involves creating a copy of our assumptions and then calculating the average customer value over the last 90 days for each segment. We achieve this by grouping our data according to the defined segments and extracting the mean values for M90D, which represents that average. The use of reindexing ensures that our new average values align correctly with the segments listed in our temporary data frame. Next, we introduce the concept of a break-even uplift percentage, which helps us gauge the minimum increase in customer engagement needed to justify the costs associated with incentives and contact. Here, we define a margin of 25% and proceed to calculate this uplift percentage using a formula that factors in both the costs incurred and the expected responses from customers. It's important to recognize that this calculation relies on several key variables, including the incentive offered, the cost of contacting customers, and the average value of customers from the previous step. We then proceed to organize this information, sorting our augmented data frame based on the calculated break-even uplift percentage. This sorting action aids in quickly identifying which segments are likely to yield the most advantageous results from our initiatives. Finally, we display the top entries of this structured data frame, providing a clearer picture of the segments that warrant further attention. Looking ahead, the next cell will likely explore strategies based on these insights, possibly focusing on how to optimize engagement efforts for the segments identified as most promising in this analysis. Cell 18. In this cell, we're delving into a crucial concept in marketing analytics known as incrementality, especially in the context of RFM segmentation. While RFM, which stands for recency, frequency, and monetary value, is a powerful tool for understanding customer behavior, it doesn't automatically lead to increased profits. It's essential to assess what your customers would have done without your specific offers. The logic here revolves around measuring the actual impact of marketing interventions versus the baseline behaviors of customers. We need to scrutinize not only the likelihood of conversion, but also the value these conversions bring. Simply put, we're examining the lift created by targeting certain customer segments through offers. If we ignore the counterfactual scenario, what customers would have done without receiving inducements, we risk overestimating the effectiveness of our campaigns. An important variable to consider is the size of the incentives offered. If these incentives are too generous, there's a chance they may actually eat into profit margins, even if they seem to drive more sales. Therefore, while RFM provides valuable insights into customer segments, understanding the dynamics of incrementality will give us a clearer picture of profitability. Learners should be cautious here. Treating all spending as incremental without deep analysis can lead to misguided strategies. This involves distinguishing between genuine uplift generated by targeted offers and the natural sales that would occur regardless. Moving forward, the next cell is likely to explore practical methods for measuring this incrementality, helping us refine our understanding of how to make more informed decisions that balance customer engagement with sustainable profits. Cell 19. In this cell, we're going to create a bar chart that visualizes the number of customers within each RFM segment. This is an important step because understanding how many customers fall into each category can reveal insights about customer distribution and engagement. It's not just about numbers. It helps us identify trends and patterns that can inform our marketing strategies. To start, we gather the relevant data by using the RFM data frame, specifically focusing on the segment each customer belongs to. We use the value counts method, which efficiently counts how many customers belong to each segment. This output is then restructured into a new data frame with two columns, one for the segment labels and another for the corresponding counts of customers in each segment. Next, we leverage the Plotly library to create a visually appealing bar chart. The x-axis will represent the segments, while the y-axis indicates the number of customers in each. This makes it easy to quickly discern which segments are larger, helping us to identify where our customer base is concentrated. It's a straightforward yet powerful visualization that can prompt questions about why certain segments might be larger or more valuable. Once we create the chart, we fine-tune the layout by setting the width and height, ensuring that our visualization is clear and easy to interpret. By displaying this graph, we're not only presenting data, but also setting the stage for deeper analysis of customer behavior, such as identifying segments that could be targeted for promotions, or those that may need further engagement strategies to prevent churn. Looking ahead, the next cell will likely build upon this visualization, diving deeper into the implications of the findings and potentially leading us to strategies for targeting specific customer segments based on their engagement levels and profitability. This will allow us to refine our approach for better results. Cell 20. In this cell, we're creating a bar chart to visualize the total monetary value for each customer segment over the past 365 days. This visualization is crucial because it helps us understand where our revenue is coming from, allowing us to identify which segments are most valuable to our business. The process begins by grouping our customer data by segment. This means we're organizing the data in a way that allows us to see the relationships between different customer groups. Within each segment, we're aggregating several key metrics: the number of unique customers, the sum of monetary value over the last 90 days, and the total for the past 365 days. These metrics will help us gauge overall segment performance and customer engagement over different time frames. Once we have this aggregated data, we use a bar chart to display the total monetary value for each segment over the last year. The dimensions of the chart have been carefully set to provide clarity, with a width of 1100 pixels and a height of 500 pixels, ensuring that the data is easily readable. As you interpret this chart, keep in mind that it reflects aggregated values, meaning we can identify trends, but we might not capture nuances within each segment. A potential pitfall here is assuming that a high total value always translates to a healthy customer relationship. Other metrics should be considered for a complete picture. Looking ahead, the next cell is likely to build upon this analysis by diving deeper into either segment performance over time or specific strategies to enhance value generation within each segment. This progression will further solidify our understanding of customer behavior and value. Cell 21. In this cell, we're diving into the analysis of customer behavior by examining the average recency, frequency, and monetary values segmented by customer group. This assessment is crucial for understanding how different segments interact with our product over a recent time frame, specifically the last 90 days. The first part of our code groups the data by the segment variable, allowing us to aggregate key metrics: recency, frequency, and monetary values. These metrics give us insights into customer engagement and spending behavior. Recency tells us how recently a customer made a purchase. Frequency reveals how often they make purchases, and monetary indicates the average spending per segment. By calculating the mean for these metrics across each customer segment, we create a comprehensive profile that highlights the distinctions and behaviors of various customer groups. Next, we visualize this aggregated data using a bar chart created with Plotly. The chart compares average values of recency, frequency, and monetary spending for each segment side by side. This not only provides an immediate visual impact, but also allows us to quickly spot trends or anomalies. It's important to note that while this analysis gives a snapshot, it is based on the assumption that previous behavior will be indicative of future actions, which may not always hold true. Potential pitfalls to watch out for include overgeneralizing the segments or making decisions solely based on averages, which can sometimes mask the variations within each segment. Looking ahead, the next cell will likely build on this segmentation analysis by applying targeted strategies or recommendations based on our findings, allowing us to further refine our engagement efforts with each customer group. Cell 22. In this code cell, we're creating a captivating three-dimensional scatter plot using Plotly's Express library. This visualization is crucial as it allows us to explore customer segmentation in RFM space, focusing on how customers are categorized based on their recency, frequency, and monetary value over the last 90 days. The scatter plot is constructed with three axes: each representing one of the RFM metrics. On the x-axis, we have recency, which tells us how recently a customer has interacted with the business. The y-axis shows frequency, reflecting how often they make purchases, while the z-axis conveys the monetary value, illustrating how much money they've spent. By positioning customers in this 3D space, we're able to visually differentiate segments, highlighting those who've engaged recently, buy frequently, or contribute significantly to revenue. We've included color coding based on customer segments, enriching the visual experience and making it easier to interpret patterns and clusters. Additionally, hovering over the points provides valuable context, revealing customer IDs, the RFM sum, and tenure in days. This extra detail can enhance our insights as we analyze these segments and look for trends in customer behavior. It's important to remember that the layout has been fine-tuned to a specified width and height, ensuring that our plot is both visually appealing and functional. However, users should be cautious about interpreting the distance between points. While they offer a sense of segmentation, the perception of proximity and 3D space can sometimes be misleading. Looking ahead, the next cell will likely build on this foundational understanding of customer segments, potentially diving deeper into the implications of these visualizations, or exploring how to leverage this information for targeted marketing strategies. Cell 23. In this cell, we're creating a heat map to visualize customer density based on their recency and frequency scores. This is an essential step in understanding customer behavior, as it allows us to see how many unique customers fall into various segments defined by these scores. To start, we group our dataset by recency and frequency, denoting these as R and F. We're using functions to aggregate the data, specifically counting the unique number of customers and calculating the average monetary value over the past 90 days, which we've labeled as M90D. This combination gives us a clearer view of not just how many customers are in each segment, but also a sense of their recent spending behavior. As we move to the heat map itself, we utilize a density representation, where the x-axis represents recency scores, while the y-axis depicts frequency scores. Cell 24. In this cell, we're generating a scatter plot that illustrates the relationship between customer recency and their value over the past year. This visualization is particularly significant, as it helps us identify segments of customers who might still hold value, but are showing signs of cooling in their engagement. To create this scatter plot, we utilize the Plotly Express library, which allows for interactive visualizations. The data being plotted comes from the RFM data frame, where we've set the x-axis to represent customer recency over the past 90 days, and the y-axis to indicate their monetary value over the last 365 days. By color-coding the points based on customer segments, we can easily compare behaviors among different customer groups. The hover data enriches the user experience by providing additional insights, showing key metrics such as customer IDs, frequency of purchases in the last 90 and 30 days, as well as their tenure, or duration of being a customer. This added context enhances our understanding of customer dynamics at a glance. It's important to note that we've chosen to display the y-axis on a logarithmic scale. This decision is vital, as it helps in visualizing a wide range of monetary values, allowing us to better discern patterns, especially when there could be significant outliers in spending. When interpreting the chart, learners should be cautious about the assumptions made regarding the data, particularly how recency and spending may imply customer engagement or retention. There could be nuances that aren't captured purely through these metrics, highlighting the importance of comprehensive customer relationship management. As we transition to the next cell, we might delve deeper into the insights gleaned from this scatterplot, perhaps performing additional analysis or modeling that builds on our understanding of customer segments and their behaviors. This will enhance our approach to developing strategies aimed at re-engaging the valuable, yet cooling customers identified in this visualization. Cell 25. In this cell, we're diving into a visualization aimed at understanding customer behavior deterioration through a metric known as the frequency drop ratio. This ratio will help us analyze how frequently customers are engaging with our brand over recent periods, specifically comparing their behavior over the last 30 days to the behavior over the last 90 days. This analysis is important because it helps identify segments where customer engagement may be declining, allowing for targeted interventions. To calculate the frequency drop ratio, we take the number of engagements in the last 30 days and divide it by the number of engagements in the last 90 days, with a tiny adjustment added to avoid division by zero. This is a crucial step. The addition of this small value ensures that even if a customer has had no engagement in the previous 90 days, we won't encounter an error in our calculations. The result is a metric that indicates how engagement might be changing by segment. Next, we're using a box plot to visualize this frequency drop ratio across different customer segments. This type of visualization allows us not only to see the central tendency of each segment, but also to assess the variability, which can reveal insights about specific groups potentially facing greater issues with engagement. The title itself, Behavior Deterioration, F30, F90 by segment, clearly conveys that this is an analysis of behavioral trends across different customer segments, helping to identify those that may be deteriorating in terms of engagement. The layout adjustments we made to the plot ensure that it is appropriately sized for viewing, supporting better understanding and easier comparison between segments. As we look at the output, we should keep in mind the potential implications of identifying segments with a high frequency drop ratio, as these may become targets for marketing campaigns, customer re-engagement strategies, and retention efforts. Looking ahead, in the next cell, we'll likely build on this analysis by exploring specific strategies or actions we can take to address the engagement issues identified here. Cell 26. In this cell, we're diving into the concept of value concentration through a visualization known as the Pareto curve, which showcases the relationship between customers and their total monetary contributions over the past year. This analysis is essential for understanding how a small segment of customers can drive a significant portion of revenue, encapsulated in what's often referred to as the 80-20 rule. The code first organizes our data by sorting it in descending order based on the monetary values people have contributed over the last 365 days. By creating a copy of this sorted data, we ensure that any manipulations do not affect the original dataset. The next step involves calculating cumulative values, which gives us an insight into the total monetary contributions in an accumulative manner. We then determine the cumulative percentage of these values relative to the total sum, allowing us to gauge how the contributions stack up as we consider more customers. To compare the concentration of value, we also calculate the percentage of customers, with each customer being assigned a rank in a cumulative fashion. This means if you have one customer contributing the highest value, they represent a significant portion at the start of the curve, while subsequent customers gradually add less to the total. Using Plotly Express, we create a line graph to clearly demonstrate this relationship, mapping the percentage of customers on the x-axis against the cumulative percentage of their total value on the y-axis. The plot helps visualize the essential takeaway, how a small percentage of customers often accounts for a large portion of the total value generated. It's important to keep in mind that this analysis relies on accurate monetary data and assumes that customer behavior remains relatively consistent over time. Learners should be aware of potential pitfalls, such as skewed distributions that could misrepresent the concentration if not properly normalized. As we move forward to the next cell, we will likely build on this visualization by delving deeper into segmentation, helping us to identify key customer groups that warrant focused strategies for engagement and retention. Cell 27. In this cell, we're focusing on visualizing the expected profit by segment, which is critical for understanding the effectiveness of different marketing strategies. By analyzing this data, we can identify which segments contribute the most to our overall profit, helping to inform future campaigns and resource allocation. The first step in this process is resetting the index of the profit by segment data frame. This operation ensures that our data is organized neatly, making it easier to reference the segments when we create our visualization. Next, we leverage the Plotly Express library to generate a bar chart that displays each segment along the x-axis and its corresponding expected profit on the y-axis. This visual representation allows us to quickly assess how each segment performs in terms of profitability. A notable addition to our bar chart is the horizontal line set at y equals 0, represented with a dash style. This line provides a clear demarcation, instantly conveying which segments are generating positive profits and which are falling below the break-even point. The adjustments made to the dimensions of the chart, ensuring a width of 1100 pixels and a height of 500 pixels, allow for a more engaging and easy-to-read presentation. While this visualization offers valuable insights, it's important to remain cautious about possible assumptions. For example, the expected profit figures are based on modeling assumptions and predictions that may vary in real market conditions. Understanding these nuances can prevent misinterpretation of the results. In the next cell, we will likely delve deeper into these segments, possibly exploring strategies to optimize performance or further dissecting the data to uncover the underlying factors that drive profitability. This will build on our current understanding and provide actionable insights for our marketing efforts. Cell 28. In this cell, we're delving into how to calculate the break-even uplift percentage for different customer segments, a vital metric that helps us understand the profitability of our marketing efforts. By doing this, we identify how much additional engagement we need from our customers to make a campaign financially viable, especially when considering that profits can turn negative if we're not careful. The process begins by aggregating the average monetary value over the last 90 days for each segment, which gives us insights into spending behavior. Next, we take this data and merge it with our assumptions, which include important variables such as the response rate, the incentive offered, and the contact costs associated with each segment. This integration is crucial as it allows us to see how different factors interact with each other. A key step here is calculating the break-even uplift percentage, which combines the incentive and contact costs divided by the response probability, all adjusted for the average monetary value and our defined profit margin. Essentially, this formula tells us what percentage increase in engagement we need to achieve to balance our costs against potential revenues. It's important to remember that misestimating any of these assumptions, like response rates or costs, could lead to unreliable insights, so careful evaluation is essential. After we've computed the break-even uplift percentage for each segment, we visualize these results with a bar chart, which helps convey the information clearly and allows for quick comparisons across segments. By sorting the data before plotting, we highlight which segments may require more focus in terms of boosting engagement. Looking ahead, the next cell will likely build on this analysis by diving deeper into strategies for improving these uplift percentages. We could explore targeted marketing approaches based on the insights gleaned here, aiming to optimize our efforts and financial outcomes even further. Cell 29. In this final cell, we reach an important milestone in our analysis. This signifies the conclusion of our current exploration, wrapping up the insights and findings we've gathered along the way. Throughout this journey, we've developed a comprehensive understanding of our dataset, tested various hypotheses, and drawn meaningful conclusions. The important variables we've been analyzing helped us uncover trends and patterns that can inform future decisions or guide further investigations. It's worth reflecting on the assumptions we made, which have shaped our results, and recognizing any limitations that might affect the robustness of our conclusions. As we transition from this cell, it's essential to recall the significance of documentation and clear communication of our findings. Whether in a report or a presentation, how we convey our insights can have a direct impact on stakeholders or peers. Looking ahead, the next cell will likely prompt us to think about how we can visualize these findings. Using visual tools can be incredibly powerful in making complex data more accessible and engaging. This will not only help in conveying our message more effectively, but also in sparking further inquiry based on the visuals we create. Let's prepare for that next step, where we bring our findings to life through graphical representations.